All right, this video is talking about solutions and inequalities. We are starting on page 88, and this just kind of introduces the idea of what can go in and to make a statement equal or balanced. So obviously 2 plus 2 would be 4, or 2 times 2 would equal 4, or even 1,000,000 divided by 250,000. Okay, the sky's the limit really here. So it's this kind of an open-ended type of questions. Same thing with 2, 4 plus 5 would equal 5 plus 4, or 4 plus 5 is equal to 9, 4 plus 5 is equal to 3 squared. And I like these because this shows that not only is it a single number is equal to an expression, but an expression could be equal to another expression. Okay? Skipping to the next page, we see an equation. Is a statement of equality between two expressions. So an expression, can be a term, it can be a variable, a number, or a combination of the two. An equation is two expressions that are equal to each other. All right, and then we got into looking at solutions. Several options. It can be a solution could always be true, or an equation could always be true, could be never true, or it could be true for certain values of the variable, or sometimes. All right? And then I already gave you these expressions down here, or sorry, equations. I'll get it right here. These equations, and asked you would they be sometimes true, always true, or never true. And x times 2 is always going to equal 2 times x. And this one looks like it would never be true, because if you take x and you multiply it by 2, it's not going to still equal x, unless x is 0. So that is a possibility. All right, so that would make this a sometimes instead of a never, because there is one possibility which makes it sometimes. And then this one, there's one solution, so it would be sometimes. Okay? And then over here, introduces the idea of a solution, and this is really important. A solution to an equation is a value for a variable that makes the statement true, or the equation true. So if I can put a value in for a variable, and it makes that statement true, I just put in a solution. Okay, so x plus 3 equals 7. Which of these in this set? Again, these are braces, okay, identifying that I have a set of numbers. This 4 is a solution to this expression. It's the only one in this set that makes that statement true. And it happens to be the only number ever that makes that statement true. But in the options, it's the one. All right? And then in this case, my 5 would be the statement that would make this true. All right, and then this is the only one that's available, so obviously 0 is going to make the statement true. Okay, now moving on to inequalities. All right, to graph the inequality, we're basically graphing all the options to make the statement true. Okay. So you probably have seen these signs before. Maybe these two are a little bit new. All right, we'll get into what that line means in just a little bit. But if I look at x is greater than 3, all right, I'm looking at all the values that are bigger than 3. So like 4, 5, 6, 7, 8, even 3.00000001. Okay, that is more than 3. Any of those numbers over here would make this statement true. Okay, now if I put the line under that greater than sign, it means or equal to 3. Okay, so it's really no different except that now it can be 3. 3 is a solution to a set. Now it doesn't mean it's both greater than and equal to. That's not possible. Okay, that's why it says or. So if it's either greater than 3 or it's equal to 3, then it's a solution to it. And since 3 is greater than 3, it's a solution. Okay, and then all these other numbers above it. Okay, now compare that to this one. All right, now we have x is less than 3. So these are all the values that are less than 3. Okay, so anything that's graphed could be a solution for this. Now notice we have a circle around the 3, meaning it cannot be 3. 3 is not a solution to this. So we put a force field, if you will, around it. Okay, and then we put the dot here, meaning, yeah, okay, it could be 3. All right, so we allow 3 to be a solution in this situation. It's not up here, but it is down here. Because anything over here would make that statement true. All right, now the tricky part. They give you a graph. You've got to identify what the inequality looks like to make that happen. What I do is I start with the x and then the value that is graphed. Okay, so here in blue, I put an x here and I put 15 here. Okay, because I know that this somehow 15 is going to be involved. Okay, so then I think, now, what values are being graphed? Are these values less than 15 or more than 15? Because remember, whatever is shaded, that's what x could be. So for example, 12. If I put 12 in the place of x, is 12 less than or equal to 15? Well, it's less than. So I would put the sign this way. Now, could 15 be a solution in this situation? Well, it must be, because they put a dot there, so I need to put the line under it. Right? So x is less than or equal to 15. All these values are true for that. They're less than or equal to 15. All right, on B, it's x, and I write x, and I write 16.5, because it's the number that we're most interested in. And the values are on this side. So 18 and 19, if I put those here, they are bigger than 16.5. So I put it that it's going this way. Now, can it include 16.5? I don't think so, right? There's no dot there, so I do not put a line. All right? So that's my approach. I put an x, and then I put wherever that circle or that dot is. Okay? I know we didn't get to this one. This one would mean that it can be anything but 23. Okay? So let me write that in real quick. So basically we're saying that x cannot be 23. It can be anything other than 23, but not 23. Okay? All right. Now, going the other direction. We know that we're going to put a circle or a dot on 14. So we need to ask, is it going to be a circle or a dot? Can it be 14? Well, it can, because it says x is less than or equal to 14. And now what side of x are less than 14? Well, they're over here, so I'm going to draw this. Now, I could check it by putting 10 in for x. 10 is less than 14, so that is a solution. I've graphed the correct side. Okay, what about B? Okay, is it a circle or a dot? It is a circle on 55, and x is less than, all right? So I need to put all the values that are less than 55 in my graph. So I'm going this way. Okay? All right. So your assignment is basically to do this on the back and to decide whether it's a solution or not on the front. So thank you for watching. We'll see you next time.